So if we look at this, kind of the big overview picture, the hypothalamus sits here. We have the infundibulum, which is the stalk going down to the pituitary. When we look at it from the inferior view, okay, here's the hypothalamus sitting there. You see part of it. You see the mammillary bodies up here. And you see the infundibulum there. So it allows you to orient. The pituitary developmentally is one of the most interesting structures that you own. You all probably remember learning about the pituitary. You have the anterior pituitary, or the Edina hypophysis, and you have the posterior pituitary, or the neurohypophysis. We're going to look at all of those things. And essentially, they're very, very closely associated with the hypothalamus. But one thing students have trouble with is understanding how chemicals are made and released at the pituitary. Because for one part of the pituitary, the chemicals are actually produced in the hypothalamus, and they are released. In the other part, you have glandular tissue. And it's not always real clear how that all works. In general, I find that students know and understand the anterior pituitary a little better than the posterior, even though it's much more complex. And they tend to think of it as, well, that's the normal pituitary, and the neurohypophysis, or the posterior pituitary, is the weird one. But the reality is it's just the opposite. Developmentally, there are some very interesting things going on. You go from 22 days up to the, quote, adult version, okay, 3 months. Yeah, that's kind of wild when you really think about that. But here we have the developing neural tube, all right? We have the rhomencephalon and the mesencephalon and the prosencephalon here. And this area is where you start to get this opening forming that's going to be the oral cavity. We start to see that really developing more. And going to have ectodermal thickening there. And along with that, you're going to have the extrusion of some tissue from the base of what's going to become the hypothalamus. So about 20 days later, we have the hypothalamus sitting up here. We have this cell mass moving down with the developing infundibulum here. This is going to become the neurohypophysis. Now, from the oral cavity, we have Rathke's pouch here, which is an extrusion of ectoderm, which is going to become the Edina hypophysis, or the anterior pituitary. These two are growing towards one another, but this is Rathke's pouch is going to break off, and it is going to kind of loosely be in contact with what is going to become the neurohypophysis, or the posterior pituitary. Now, this is going to present all sorts of issues and problems, because you already know that the pituitary is an important glandular organ, or it's an important endocrine organ, endocrine gland, and we're going to have lots of secretions from there. But in order to have those secretions, we need to have signals. There's nothing attaching this to the brain. What's going to happen here is we're going to have this tremendous vascular supply, once again, that is going to allow the hypothalamus to communicate with the anterior pituitary. The posterior pituitary, the neurohypophysis, is going to have direct innervation from the brain. And that's going to make it all the different. Now, understand everything involved with this, ultimately, you have to understand the nuclei of the hypothalamus. So here we have the hypothalamus. Here's the infundibulum. Down here is the pituitary. So we can see here, this mass is the adenohypophysis. This, coming down like such, is the neurohypophysis. Now, the nuclei in the hypothalamus are really critical to many of your homeostatic mechanisms. Everything from circadian rhythmicity to temperature control to anything that requires pituitary hormones. And it's important to know the nuclei involved. We have this preoptic area, we have the anterior group, the middle group, the posterior group. We're going to look at all of those. We're going to divide them up and look at how they come together. So this preoptic nucleus here, medial preoptic nucleus. All right, that's the only one in the preoptic group. We have 1, 2, 3, 4 in the anterior group. Paraventricular, anterior nucleus, the suprachiasmatic and the supraoptic. Suprachiasmatic, above the chiasm, supraoptic, above the optic nerve. So you start to get a feeling for how they're named. Paraventricular, the ventricle sits right up above that one. We go to this medial group here, dorsal medial nucleus, ventromedial nucleus. Okay, dorsal and ventral. That makes a little bit of sense. And then we have one of the ones that has just an outlier name, the arcuate nucleus. The arcuate is critically important. We're gonna look at that in just a minute. And then in the posterior group, we have 2 nuclei. The posterior, duh, that's easy, and the mammillary body. The mammillary body is actually made up of a bunch of little nuclear areas that are all lumped together. It was described as the mammillary body long before the nuclei were named, and in general, we just refer to it as such. Oh, yeah, one second. So, you've got 1 preoptic, 4 anterior, 3 medial, and 2 posterior. 1, 4, 3, 2. I kind of think about it as 4, 3, 2, 1. However, whatever works for you. There's a rhythm there. So we have 1 preoptic, 4 anterior, 3 middle, 2 posterior. 1, 4, 3, 2. But look at the pattern here. 4, 3, 2, 1. The one's at the front. Okay? Yes?
I was just curious as to why it's called the mammillary body. Is that just because
They're your brain's 2 little boobs. Mammillary as in breasts. They're the 2 breasts. Thank you for asking. Well, sorry. Oh, hello. That's okay. Here we go. Yes. There are people that divide the preoptic nucleus into 2 areas. I believe in the text of your book it describes them as such. I would like you to lump them together. Sleep regulation, critically important. Osmoregulation, the osmolarity of your blood. Thermoregulation, fever and hot flashes. All right? this is an overwhelmingly female group, at some point in your life you will experience hot flashes. Guys, you probably will too, in a very different way. Hot flashes come when you lose some of this thermoregulatory issue, some of the thermoregulatory abilities. Yes?
Is this why old ladies are always cold?
No, you know, people, and it's not just old ladies, old guys get that way too. As you get older, you lose some of the thermoregulatory ability. In general, it's moving today. You're becoming less able to control all of your metabolic processes. So your metabolic rate is actually dropping, and so there's a lot involved with that. However, women typically from about 55 to 65 go through this tremendous period of menopause, from being perimenopausal to postmenopausal, where estrogen levels are fluctuating. Fluctuation in estrogen is going to kick hot flashes. And I mean, seriously, you know, everybody kids about hot flashes. Hot flashes should be taken seriously. I mean, think about you sitting there, okay, you're quite comfortable and everything, and all of a sudden, your body temperature shoots up enough to where you start sweating. I mean, literally, sweat could be dripping off of you. So it is something to be taken very seriously. Even though comedians are always joking about it, I'm surprised they don't get punched out. So, sleep, osmoregulation, thermoregulation in the preoptic nucleus. Paraventricular nucleus, production of oxytocin and vasopressin, or antidiuretic hormone. Now, if you remember back to what you've learned about the pituitary, you know that these are the two hormones that are released in the posterior pituitary or the neurohypophysis. The anterior nucleus is involved with thermoregulation in cooling events. Suprachiasmatic nucleus has inputs from the retina. There are also some inputs here from the pineal gland that involve circadian rhythms. So, you know, we're starting to see the importance of this structure. The supraoptic nucleus produces only antidiuretic hormone. So we have two nuclei producing antidiuretic hormone. This is such an important chemical for you. It helps you control blood pressure. It helps you control dehydration events. Dorsal medial nucleus, ventromedial, and arcuate. So now we're in that middle group. Dorsal medial, feeding, drinking, weight, circadian activity. Fear, feeding, fever, and sex. You know, wow, yes. So you go out on a hot date to eat and you're afraid. Bang, that's it. So, yeah, whatever works. What you have to see is frequently people who have behavioral issues, such as fear, also have issues with maybe weight. And it does make some sense. When you see, you know, when we try to show you some of the physiological mechanisms involved with some of these nuclei, you know, it should help tie together some association between different types of behaviors. The arcuate nucleus is monstrously important. There's some dopamine that it produces that's going to go into some reward pathways. Release and inhibitory hormones. These have tremendous effects on the pituitary. We'll talk a little, well, we won't get to neuropeptides.